Okay, so now that we have gone through and discussed how to solve for a missing side length using trigonometry, we're now ready to move on to the second stage, which is to find the measure of a missing angle. So before that, though, there are a few ideas that I want to present to you so that you understand why we're about to do what we are about to do. So, for example, in math, we may say to you, all right, if I had x plus 3 equals, let's say, 7, well, how would we undo that addition? Well, we would undo it by doing the opposite operation. We would undo the plus 3 by subtracting 3. Right? And if I had, for example, a multiplication like 2x equals 10, I would undo that multiplication by dividing out the 2. And so lastly, if I had, let's say, something like an x squared equals 16, well, how would I undo the squared to isolate my x? Well, I would take the square root. Now, in trigonometry, if I want to, let's say, for example, I had the sine of some angle x equals 0.8, for instance, then how do I isolate x in this case? How do I get this x all by itself? Well, sine of x is not really a multiplication, so I can't just divide out my sine and divide out my sine. That's not how that works. Do not do that. In math, the button that tackles the inverse of sine is the sine to the -1 button. So for example, if I had this case above, sine of x is equal to 0.8, then I would undo that and isolate x by taking the sine to the -1 of 0.8. Now, that's just an introduction, so we're going to talk a little bit more about the sine to the -1 button and where to find it and then how to use it. So I've pulled up this diagram here of your calculator. So to solve for an angle, and this is, I would say, one of the areas where students forget what to do and when to do it, and also how to use a particular calculator. You maybe saw yesterday that you had to fiddle a bit to figure out your calculator, and so every calculator and its trig functions are going to operate a little bit differently, and so it's good practice to just stay with a particular calculator and know how and be comfortable with it and know how it works. So to solve for an angle, as I just mentioned, we're going to use these to the -1 buttons because we're going to solve for an angle, we're doing the inverse of solving a side length. So we need to use the inverse button on our calculator. So you will probably notice those above the regular trig buttons as sine to the -1, cos to the -1, tan to the -1, and usually you'll have to press a second function or a shift button of some sort to get to them. But make sure you can find those and that you know how to use them. We'll have some practice examples to make sure that you can. All right, so take a minute to write down, to draw this example out. In this example, I can tell based on the symbol here that it's angle A that is being sought out. And so I'm going to take a look at labeling my triangle as opposite, hypotenuse, and adjacent relative to this angle A over here. So just take a minute to do that. I'm going to do it as well. So I can see that my hypotenuse is this 9 centimeters because it's opposite my right angle. And so I look at the angle in question, which is angle A, and I can see that opposite it is, that's the opposite side. And then the other arm of angle A, other than the hypotenuse, is my adjacent side. And so now I have to remember SOHCAHTOA, right? So SOHCAHTOA, I'm going to write it up here, because it's my friend when I do right-angled trig. And I'm going to look and see, well, in my triangle, what information do I have? Well, I have this 9 centimeters, and that's my hypotenuse. And I have this ooh, I'm going to just do something real quick here and change this 6 to 6 centimeters, because this was not meant to be, they weren't meant to have different units. And then so now I'm going to take a look at my adjacent side, the 6 centimeters right here. And I can see that, you know, my opposite side isn't being used at all, which means that when I go ahead and I look for the correct trig function, anyone that has an O opposite in it can't be used. So I can't use sine. And it looks like I can't use tan because it has the opposite side. So the correct trig function here would be the cosine function. So let's go ahead and set up our formula as we normally would. So in this case, I would say, all right, well, so I'm going to say that I know that the cosine of angle A, and you know what, I'm going to just change that because, you know, sometimes students forget that that A is an angle, so it may be helpful for you to write in cosine of angle A. That way you remember you're solving for an angle, is equal to always my adjacent over my hypotenuse, right? And so the cosine of angle A is going to be equal to, and I go ahead and I look here, well, my adjacent side has a measure of 6 centimeters, and my hypotenuse has a measure of 9 centimeters. And so at this point, you know, you can go ahead and calculate this out as a decimal and have it in your calculator, but we don't really care so much about what 6 divided by 9 is. So this is how I would go about this, but it really depends on your calculator, and I'm going to talk about how you would input the data into your calculator to get the right answer in a minute. But I would typically just, this is how I would write it out. I would say, well, you know, oops, I would write out, well, angle A, I'm going to undo this cosine. Angle A is equal to cos to the -1 of 6 divided by 9. And so what does that look like when I type this into my calculator? Well, again, it depends if you have a forward or a reverse calculator. So if you have a forward calculator, you're just going to type it in exactly like that. You're going to press usually your second function, and then your cos to the -1 button, which will be your cos button. And then I would put in, often you have to put a bracket, so like your parentheses, and then I would go 6 divided by 9, and then close parentheses, and then don't forget to press equals. And when you do that, what you should end up with as an answer for angle A is 48, I'm rounding to the nearest degree, 48 degrees. Now, this is going to look a little bit different if you have a backwards calculator or a reverse calculator, so I'm just going to minimize this a little bit, and I'm going to show you what those steps would look like. So if you have, like, I'm going to call it a reverse calculator, I would say in that one, and that your iPhone is actually a reverse calculator. When you kind of put it on its in sort of like a landscape orientation, then it will be a reverse calculator for you. So so if you're missing your calculator, then this is how your phone will also work. So I just did this, and when I typed in first the 6, and then the divided by, and then the 9. And then I did an equals, and that gave me a value that was a decimal. And then I went ahead and I pressed the second function. And then when you do that, all of your buttons, if you're using your iPhone, will switch to the -1. And then I pressed cos to the -1, and then equals, and that gave me my 48. So I would try that. And in fact, I'm not even sure if I needed to press the equal sign now that I think about it, but I may have needed to. So you can let me know about that. But there we have it, 48 degrees. So if you're struggling with that, let me know and I'll try to, reach out to help you. Let's try another example. Okay, so what I want you to do in this case, and I haven't indicated the angle, I'm going to say let's do this, let's find out angle X in this question. So take a minute, I want you to pause the video and try this question on your own and, come back when you feel like you are ready to take a look at the solution. All right, so I'm going to go ahead and solve this by finding angle X. And so I'm going to label my sides. So here's my hypotenuse, opposite my right angle. Then I have my opposite side, which appears to be the 7 feet. And then that leaves the other angle of my angle X, the other arm of it, and that's the adjacent side. So remembering SOHCAHTOA, I'm going to see, well, what information do I have? Well, I have information about my opposite side and my adjacent side. So I'm really hoping that you knew that that meant that you needed to use the tangent function. So let's go ahead and solve this. So I know that the tangent of angle X is going to be the ratio of my opposite side length to my adjacent side length. So the tangent of angle X is going to be that 7 feet over my 12 feet. So now I'm going to isolate angle X by saying that tan to the -1 of 7 over 12 is going to give me my angle X. So when I go ahead and I type that into my calculator, the answer that you should be getting, rounded to the nearest degree, I didn't specify, but let's do it that way, you should get 30 degrees. And so there it is. Let me know if you struggled with that, and I'll try to walk you through it. But there it is. Let's try another example. So one last example before we move on. So again, pause the video, attempt the question, and then come back when you are ready to see my solution. All right, so I'm going to take this up. I can see that my hypotenuse is across from the right angle. Here it is. And the side opposite my angle in question, which is Q, is right over here, which leaves the third side as my adjacent side. So when looking carefully at the information that I have information about my opposite side, and I have information about my hypotenuse. And so I don't know anything about my adjacent side, which means that cosine's out of the question, and tan is out of the question, and I should have used the sine function. Hopefully you chose sine. If you didn't, you might want to pause the video and start again from here. So filling things in, I know that the sine of angle Q is equal to the ratio of my opposite side length to my hypotenuse length. So the sine of angle Q is going to be the length is 120 centimeters divided by my hypotenuse length of 140 centimeters. So now I'm going to isolate my angle Q by saying that's equal to sine to the -1 of 120 over 140. And there I have it. So angle Q is going to be, when I put this into my calculator, you should be getting 59 degrees as your answer. Again, if you're struggling with calculator use or anything for that matter, feel free to reach out and we will try to work together to solve the issue. All right, so one last note, because you will eventually see questions like this where you are asked to solve a triangle. So the question will say, solve the following triangle, and you need to know what they're asking you. So when in trigonometry they ask you to solve a triangle, that means that you're going to find all of the angles and all of the side lengths. So find or calculate all angles and side lengths. That is what is meant there. So, the strategies that you're going to use besides sine, cos, and tan, because, sine, cos, and tan are handy, but they're not the only or always the most efficient way of finding the information that you need. Let me explain to you what I mean. So, for example, Pythagorean theorem we reviewed. So that may be an easier way to solve for a side. It may be the only way to solve for a side, but no, actually, maybe not. So then triangle sum. So the triangle sum we know is 180. So for example, let's look. I've picked out a couple of triangles here for you to take a look at, and we're not going to solve them because that would take too long, but I do want to talk about strategy in terms of steps. So first I want to look at this triangle right here. So I can see that it has one side length that is 24 and another side that is 30. And so there, if I'm trying to find out information about this last side here, one option certainly would be for me to use Pythagorean theorem to find the length of that third side. But that's not the only first step that I could take. I could use trigonometry to solve for an angle first. So for example, I have here, it looks like this is my hypotenuse and my adjacent side. So I could solve for angle C first and then use that information with another trigonometric ratio to solve for my side AB. So that's one option. And so another thing that you could do, well, let's look at another example. So in this second example here, you may be saying, okay, well, I can solve for a side length, the third side, another side length, either x or this hypotenuse, and then find this angle here. But an easier way to do this would be to remember that, I have an angle right here that I know is 90 degrees. And I have this angle, which is 28, so I know triangle sum will allow me to easily solve that third angle. So that may be quicker than using trigonometry. And then that opens you to other options for how you might solve for some of the other pieces of information. So when solving a triangle, the short answer is there are different ways to approach solving it, and different pieces of information you can solve for first, though some may be more efficient than others. Ultimately, there's a little bit of choice there for you. So there it is, people. I'm going to be assigning you a worksheet for this so that you can practice these skills. And as always, reach out with any questions that you might have.